Hi and welcome to my Python YouTube channel. It's awesome to have you here. If you like this video, a thumbs up would be great. And make sure to subscribe for future videos. I also have a blog at prosperocoder.com with lots of cool stuff, so feel free to check it out. Here's another video in the Functions in Python series. If you haven't watched the previous ones, feel free to do so. They include Introduction to Functions, Functions with Parameters, the Return Statement, Mandatory Parameters, Optional Parameters, Mutable Optional Parameters, Keyword Arguments, Arbitrary Number of Positional Parameters, Arbitrary Number of Keyword Parameters. Today we'll learn how to pass an arbitrary number of both positional and keyword parameters to a function. Now here we have a function with one positional parameter, an arbitrary number of positional parameters, and an arbitrary number of keyword arguments. Now let me here just move it to another line so that we can see it. And now here, depending on how many items there are in cities and workers, the output may differ. So for example, if the number of cities is greater than 0, we get this message. If the number of cities is greater than 1, we have another message printed, and then each city is printed one by one. And if there is at least one worker, so if this is not 0 elements, then each worker is printed one by one too, in a format that we specify over here. And now we're calling the function here. So the first argument here, breadmasters, corresponds to the first parameter, positional parameter, company name. Then we have a couple positional arguments: New York, Chicago, Sacramento, Atlanta. These are all the cities, so positional arguments. We can have an arbitrary number of them. Here we have 4. Finally, we have Mike Harrison equals Baker, Tom Wilkins, Baker, Sue Ernest, manager. We have 3 keyword arguments. We could pass any number of keyword parameters naturally because we have this double star notation here, but here we have 3. And now let's run this program. So here's the output. Breadmasters, our company is based in New York. We have factories in, and here are the cities, our workers, and here we have the workers and their positions, the jobs, just in the format we specified. Good. Now, if we try to run the program with different parameters, we'll get other results. Here are some examples. First, let's run it with one star argument and multiple double star arguments. So here the only one star argument, which is in cities, is New York. And we have 1, 2, 3 keyword arguments. So now if I run this, the output will be our company is based in New York. This is different than before. And here we have our workers. And now let's run the function with no star arguments and multiple keyword arguments. So here we have only one parameter. So as you can see, now we have no cities and we have 3 keyword arguments. Let's run it. Breadmasters, our workers, we don't have any information about the cities. And now let's call the function with multiple star arguments and no double star arguments. So just positional arguments here. And the output now is our company is based in New York. We have factories in, here are the cities, and we don't have any information about the workers because there are no workers. Good. And now let's call the function with just one argument, breadmasters, which is the mandatory one. And here's the output. Breadmasters, that's it. If the number of parameters is not fixed, we say the function has indefinite arity. Such functions are sometimes called variadic functions. In Python, we often use the args-quarks notation, or rather star args, double star quarks. So if we have a function that may take any number of positional and keyword arguments, we write it like so. The name of the function, star args, double star quarks. But this is naturally not part of our code. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.